Hello and welcome to another episode of That's Absurd. Please elaborate, the show where we take goofy, silly, ridiculous questions from you, the listeners, and then we go off, we tap, tap, tap on our little keyboards, and we tap, tap, tap on our phones to maybe call some people, and then we tap, tap, tap to write down the things that we discovered from tap, tap, tapping on our various other tap, tap, tappables, and then we repeat those words that we tap, tap, tap down to each other. I'm one of your tap, tap, tappers, Julian Huguet.
Wow. I don't...
Just tappa, tappa, tappa.
Just tapping away.
Tappa, tappa, tappa.
Tapping. Oh, I'm the other one. I also tap, I guess. I think of it more of as like a clickety, clickety, clickety.
You're a clickety, clackety.
I don't use my phone for much.
Tappity.
I thought you were like saying you're... Oh, I didn't say my name. I'm Trace Dominguez, also a science communicator who does the thing that Julian just mentioned.
Yes. Not a name communicator.
No.
Usually.
If you've never tuned into our show before, we answer questions that you, the audience, send us to answer. Usually those questions we ask to be ridiculous or out there or, whatever, incredulous, I don't know, other words, adjectives of various types that are not...
Possibly even absurd.
Oh, yes, absurd even. And then we go and do the research, again, with the tapping.
Tapping.
Yeah.
A lot of tapping involved.
Yeah. So, anyway... I hope you enjoy it. If you want to know how to submit a question, go down to the show notes or keep listening and we'll tell you later. In the meantime,
let's launch into it. Trace, you're up first this episode. What's your question?
My question this week comes from Sean from the UK, who sent us a voice note.
Hi guys, Sean from Lincoln in the UK here with this question for you. What is the smallest creature that could be knocked out with a punch? For some reason, I always choose to punch a fly out of the air rather than swatting it. But the fly, though it seems briefly dizzy, flies away unharmed. On the other hand, we know that a human can knock out another human with a punch. Now, a stronger man than I maybe could knock out a fly with a punch, but there must reach a point at which a creature is so small that that would not be possible. How small would it have to be? Not a psychopath. Cheers.
Good disclaimer right at the end there. Oh, I was worried for a minute, Sean. I was like, this guy sounds like a psychopath. But now that that's been cleared up, I feel a lot better about answering this question for you.
I just want to point out, firstly, I think Sean meant sociopath, because I used to get these two confused all the time, so I looked it up. Sociopath is the one that is just like violent. Psychopath doesn't understand social contracts and manipulates others. They usually don't have guilt or remorse or empathy, and they don't necessarily feel emotions, but they can pretend that they do. They typically don't form emotional attachments and are known for manipulative tendencies, whereas sociopaths are just volatile and harmful and mostly aemotional. They don't follow social norms, are aggressive, reckless, impulsive, irresponsible, and often end up in prison.
So... really, we should be worried that Sean didn't say, not a sociopath.
Oh, God, maybe Sean is a sociopath.
Not a psychopath. You left that possibility open.
Oh, no!
Oh, no!
See, that's what you do. You go around being like, guys, I'm not a psychopath.
I'm not a psychopath.
I don't know how to pretend how to be emotional.
My favorite was the chipper tone to it. Just, not a psychopath.
Yeah. Good job,
By the way.
Okay. Sean.
That's going to be another tag that people start adding to questions.
Not a psychopath.
Not a psychopath.
Not a sociopath. Okay. So, being knocked out is weird. Have you ever been knocked out or like passed out or anything like that?
Yes. As a matter of fact, honestly, I have.
Look. I don't have this in my script. I just felt like maybe we should talk about it. As soon as I asked, I'm like, definitely Julian has had this experience.
No, definitely Julian has been unconscious involuntarily at some point.
Yes, please tell us all, and me for the first time.
Yeah.
Because I have never heard this.
You want to know who did it to me?
It wasn't me.
It was me.
Oh, no.
I knocked myself out.
How?
I was 19. I was going on a ski/snowboarding trip with a bunch of college friends. I was trying snowboarding for the first time. I'm a pretty good skier, but I was like, I'm going to learn to snowboard and be cool.
Yeah, snowboarding.
And my mother, in her infinite foresight, was like, you should wear a helmet. And I was like, Mom, helmets aren't cool. You know what's less cool? Being unconscious by yourself on the side of a mountain in Canada.
Did you pee yourself?
That's way less cool. I did not. Good. What I did was I was learning to snowboard. I was going around a turn and I wasn't good enough at carving to make the turn. So I went over the side and I tumbled and I folded myself clean in half like a taco. I hit myself in the head with my snowboard that was attached to my feet, which coincidentally, the brand of the snowboard was Head. And I knocked myself out cold for like 10 minutes with nobody around me. Whoa. And then I got back up and I wobbled to the bunny slope where I collapsed covered in blood. And a young girl came over. She was also on this college trip. It was a big group. And she was like, oh my gosh, are you okay? And I was like, hi, nice to meet you. I'm Julian. I'm here from UC Santa Cruz. What school do you go to? And she was like, you need a doctor.
She's like, also UC Santa Cruz. We're friends.
I did not get her name.
Oh, okay. Well,
anyway,
she got
or
yours.
Number or anything. She's the one that got away. I don't know. Maybe she wasn't even real. Who knows?
Honestly,
I can't
yes.
say.
Maybe. There's no proof that she exists.
No way of knowing.
Wow. I have never knocked myself out. I have passed out.
Or been knocked out in general by someone else?
I've passed out, but never been knocked out. One time I passed out. I think I just stood up too fast.
That's not as good of a story.
That's kind of embarrassing. Not cool. I stood up too fast. I passed out, and I woke up on the floor. And I was like, what happened? Luckily, I didn't hurt myself. But anyway, being knocked out is weird. So I was like, okay, first, in order to understand if we can knock out something with a punch that is smaller than us, I felt like I needed to understand how we get knocked out. Like, what is being knocked out? So a KO in boxing, for example, I have Puerto Rican ancestry, so boxing is huge in Puerto Rico. So this was interesting because I'm not a huge blood sports, fighting sports fan. I find it to be quite violent and not my cup of tea, but, you know.
I'm with you. I'm a hockey fan, and I don't like the fights in hockey.
I don't mind the fights in hockey. I don't like them. I don't think it's part of the game, really. There are people that would argue that it is part of the game and historically blah, blah, blah. And it's like, it's fine. I don't find it to be as violent as I'm going to bludgeon you until you are no longer awake.
I'm just more anti-brain damage as a whole, you know?
That is the main impetus for why I'm not into these sports is because it's similar to American football and many other sports. I don't think that your brain health is worth the entertainment dollars.
Yes.
That's really what it is. You're like, I'm going to destroy my brain and you're going to pay me for that. And I'm like, so I'm not into that.
Oh!
That's not my thing. But if it's your thing, I'm not going to yuck your gum. So, long story short, when you think about the brain, I want you to think about where it is. It's inside of a big bony box.
The butt. The head, right, yeah.
Unless you're Crag, and then it's in an abdomen somewhere. But otherwise, you're in a head. But if you think of the brain, because it's basically like Jell-O, like kind of firm Jell-O, inside of a skull, and then you slap the outside of the skull. Or, for example, a bottle of water, like a gallon jug of water, or like a large bottle of water. You slap it, what happens to the water inside?
Sloshes around.
Sloshes around. Your brain does the same thing. It is mostly fat. Fat is mostly water. When you slap the skull, the brain sloshes around in there a little bit, and it hits the skull walls. No matter how many pads, helmets, hard thingies that you wear on the outside of your body, the brain doesn't have a seatbelt on, so it's going to move around. If you stop the skull moving, the brain crashes into it, similar to if you're not wearing a seatbelt in a car and you stop really fast. This crash damages the brain. It damages it every time it happens. It is never an okay thing to smash your brain into a wall. Eventually, that damage becomes severe, and people have trouble controlling their extremities. They can have trouble thinking and focusing. If it's in an acute situation like a knockout, people become quote-unquote flat-footed. Basically, the brain's been knocked around so much, it's having trouble focusing on what it's doing, and it can't coordinate arms and feet. And so you can tell that somebody's about to be knocked out. It has trouble being a brain. At this point, a lot of boxers typically, some will literally drop their defenses because they just can't control their arms anymore. The brain is crying for help, and then they get punched and they fall down. So people who are knocked out usually had some kind of interruption severe enough to cause unconsciousness. There are several hypotheses as to why our brain kind of goes into this hibernation mode when it's damaged. We don't actually know why we get knocked out. We know it happens because we see it, but we don't know what specifically. It's not just like, oh, well, this happens and then that causes the brain to go into this temporary shutdown and then it comes back. By the way, short-term post-concussion symptoms, because all of this is what we're describing is basically concussions. Anytime your brain hits the wall of the skull, it is a concussion, maybe not a severe one, but it happens every time. Concussion and knockout, two completely different things. You can get a concussion. You probably had a pretty major concussion from your snowboarding incident. I probably had a pretty minor concussion when I passed out after standing up off the couch. But
we are not the same.
We are not the same. However, you don't have to go unconscious in order to have had a concussion. You can have a concussion and never lose consciousness at all. Concussions can cause memory problems, mood changes, confusion, slower information processing, and long-term, lots of concussions can cause problems with controlling your body. They can cause problems with CTE, Parkinson's, personality changes, dementia, even word finding can be serious and debilitating. I say all this not to bum everybody out, but to be like, this is a pretty wide-ranging problem. And so to put a pin in it, like that scientific method, we want to find out, you're knocked out, you're not knocked out. That's it, right? That's what we're trying to find with this scientific study. That's real hard to pin down because so many other things are happening. And the brain doesn't like stop working and just was like, oh, well, I guess I'm knocked out now. You know?
Go sleep time now.
Okay, goodbye. So traditionally,
the brain is a Muppet.
the brain is a Muppet.
Grover.
Hello, everybody. I'm Mr. Brain.
I'm a brain. Why are you hitting me?
Ow. So think about your brain again, but think of it from like an anatomical model. So you've got the head with the brain kind of jutting out into the front, and then it kind of goes around the back, down the brain stem into the spinal cord, and then out to the rest of your body. Now, all that obviously is not the brain, but that's all part of your nervous system. The brain is a pretty big part right there at the top.
Yeah.
So there's this term in boxing called the glass jaw. Have you heard of this before?
I know people who get knocked out fairly easily might have the moniker of having a glass jaw. I've also heard that, and I mean, I think I learned this from the 1970s movie Rollerball. So I don't know how accurate it is.
Yeah.
But basically, if you hit somebody on the chin or on the button, you know, in a certain way, like the force travels through the jawbone and into some other bones in the skull, and somehow that causes a knockout.
Right. It's not really the bones as much, they think, for some of the different hypotheses. And we're going to go through all the different hypotheses, basically 4 major ones. But what the major hypothesis that I think is interesting is twisting the brainstem. So if you think of it like your brain is attached to the brainstem, but remember, it's just floating in fluid inside your skull. If you punch somebody at the right angle, it twists the brain keeps moving after your head stops moving, and so it smashes against the side of the inside of your skull and has twisted the brainstem, and they think that is one of the ways that we might lose consciousness, because, but let's come back to that in a minute. There was a guy named... Just like,
I'm just imagining like a game of bop it on the chin, and then twist it,
pull it,
knock it out.
So there was this guy named Dr. Harrison Martland, fascinating dude, famous for discovering why watch dial painters were developing jaw necrosis in the early 20th century. Oh, Julian has the smile of a person who knows why these watch dial painters were developing jaw necrosis. Do you want to tell us all?
It's kind of sad. The radium girls, right? These were women who would paint watch faces, and they would use this, fancy new glow-in-the-dark material called radium.
Yes.
And they would paint the numbers, and they would lick the tips of their brushes so they'd be fine points, and they'd have radium on it, and so the radium would go into their mouths and it would radiate their gums and decay their gums.
Yeah. One of our buddies, Matt Morales, when we were back at Seeker, made a video about the radium girls. Really interesting if you want to go watch it. But yeah, this was a real thing that really happened prior to workplace safety laws. They had...
Can't imagine why those are a thing now.
Yeah, they had their jaws slowly disappear until they didn't really have them. Yeah. This person, Dr. Harrison Martland, discovered why those watch dial painters were developing this jaw necrosis because of the radium, but also was one of the scientists studying the brains of quote-unquote punch-drunk fighters. Common in the 1920s during boxing. So personally, I thought it would be interesting if it had something to do with people coming back with lots of PTSD and shell shock from World War I. But it was even more complicated than that. He found serious damage in people's brains, signs of previous small hemorrhages, scar tissue that had replaced brain tissue. Think about what is happening to the face of a boxer, just getting pummeled. The brain has the same thing happen. It's just you can't see it. Mm-hmm. So the scar tissue replaces brain tissue that interferes with normal brain function, and that causes quote-unquote punch-drunk syndrome, which is characterized by slow thinking, word-finding problems, shuffling, unsteady gait, tremor, severe dementia. So how can a punch knock you out? Luckily for me, I found a paper titled, How Can a Punch Knock You Out?
Oh, wow. You love it when that happens.
The easiest search I've ever done. So there are several major hypotheses. The first one is the vascular hypothesis. It dates to 1924. Put simply, force causes a reduction in blood flow. Reduction in blood flow means loss of function. Could also cause tearing, like a ring hemorrhages, which is another boxing term, which could happen to some boxers. They get a hemorrhage in their brain. So you stop blood flow for a moment in the brain, and could that cause unconsciousness? They weren't sure. Maybe. The brain actually has a bit of an energy reserve, so it doesn't need constant supply of blood. It can, go for like fractions of a second without blood, and that's okay. So it doesn't really fit. It's been sort of abandoned in favor of effects on more specific things, blood cells. So in the 1940s, they came up with the convulsive hypothesis of knockouts. So we started using cameras to record boxing matches, and that changed all of the science around it, because we went from like just being able to talk about it to having video and photos of people being knocked out.
Right.
And surprise, surprise, they started realizing that as soon as the person's knocked out, they often have convulsions. They lay on the ring and they convulse. This is bad. The hypothesis actually kind of sounds like Star Trek when I was reading it. It says, force of impact triggers depolarization of neuronal cell membranes and uncontrolled release of action potential. Now, if you know what that means, that's bad.
Yeah,
that's
just
bad.
Your neurons are firing all willy-nilly.
Yeah, exactly.
Saying.
Yes. Why didn't they just say that? Jeez.
Yeah.
It's like you're a science communicator or something.
I'm good at taking big words and use small words for them.
Make small words.
Take big sentence, make small sentence.
So it looks similar to a grand mal epileptic seizure, essentially, right? You're convulsing, your brain is kind of firing out of sync. Still doesn't explain all the symptoms of a knockout, though, says this study. So then they went to microtubule hypotheses, and this is still being tested now, which I think this one makes a lot of sense. This is simply stretching of the axons of your brain. It does happen in a normal body movement situation. Nerve cells can flex, they do move, but rapid stretching from a traumatic brain injury, maybe they don't stretch quickly enough and they break. This has been demonstrated in the lab. Doesn't explain loss of consciousness still. Axons aren't really involved in action potential. They're not really part of that process. So it may explain some long-term effects of TBI. That could be like the primary injury that causes traumatic brain injuries is your axons are literally broken, but more research is needed for that. So I thought that was kind of cool.
Well, it's interesting because your axons, we talked about this in the last episode, right? But they fire because the ions, inside and outside, there's a charge difference, and they release them from inside and they flow out, and then they pump them back, and some from outside flow in. And I wonder if when you break them, if you're basically releasing a bunch of these ions that were inside of the axons just out into, the intercellular fluid.
Yeah.
Maybe. And if that has
wonder.
anything to do with it. I don't know. I'm just spitballing here. I'm just making stuff up.
Neat. So this, I think, might flow, no pun intended, well into the next one, which is mechanosensitive ion channels. They play a role in traumatic brain injury. It usually can cause a secondary brain injury. So primary injury is like, I have a cut. Secondary injury would be like, I got an infection from said cut. Or I broke my leg, and then when it healed, now I walk funny for the rest of my life, and that causes more alignment. The secondary injury is the out of alignment back that you now have. So ion channels, as Julian just mentioned, how ions move around. So when we say the brain is electrical, we don't really mean like wires. We mean this chemical ion. Sodium and potassium ions that are both positively charged are common. Mechanosensitive ion channels respond to movement. They exist all over the body, in the heart, the bladder, the inner ear. They're always working. And they're not typically connected to normal brain functions. So this hypothesis says that the potassium ion channels get disrupted, and that could cause unconsciousness. Popular Mechanics wrote this. I'm not sure why, but I thought that was kind of funny, but interesting. And they basically said it changes the balance of electrolytes in our brain cells. The brain is working to restore the electrolytes, and it happens again and again. It doesn't get to restore it. It keeps getting punched. Your brain keeps having this imbalance get worse and worse and worse, and eventually shuts down so that it can clear all of the electrolytes and rebalance everything before it can turn you back on again. Seems pretty straightforward, still a hypothesis. Reminds me of how engineers who think they know about the human body definitely always oversimplify stuff, because they're just like, well, it's just a lever and it does that. And it's like, no, It's not any of those
Have you tried
things.
turning it off and turning it back on again?
And the brain's like, I did that!
Was it plugged in to begin with? Okay, thank you very much. And click.
So then I did say 4, but I missed. There's 5. So this one is the one that is, I think, the one that is the most accepted now, because it fits the most symptoms of a knockout. The mechanoporation hypothesis. Basically, similar to the microtubule one, being hit hard causes our brain cells to stretch. But instead of breaking, we end up with these gaps, like pores in the brain that open up. The mechanoporation, or mechanical, like causing poration, affects the cerebral cortex, interrupting action potential, which is to say brain cells talking to each other. And this is consistent with the loss of consciousness without seizures that are typically observed in knockouts. Doesn't explain the seizures, but does explain why you would lose consciousness.
So it's like gaps in the cell membrane let the ions flow through instead of them going through those ion channels. They just like spontaneously can go in and out. That's basically what they're saying? It's
physical holes, like pores in the brain. So you've got hydrophobic pores and hydrophilic pores. The hydrophobic pores are unstable and they close like in a fraction of a second. They open up because the brain stretches. Now there's a gap, like it wants to stick together. So it literally opens a hole in the brain and then it closes again right away. And then hydrophilic pores, that takes them like about a few seconds to a minute or a few minutes to close. So they open up and then they slowly kind of merge back together, which is why they think that this is a really interesting way to describe a knockout, because often when you are knocked out, you are unconscious for a few seconds to a few minutes.
Right.
So they think, oh, well, maybe these hydrophilic pores opened up in a place that caused unconsciousness. And once the pore closes and the brain cells can communicate again, now we have consciousness again.
Okay.
Yeah, really interesting. Again, I want to point out, none of these know the answer. They are all hypotheses. They're all being researched. Well, maybe not the vascular one dating to 1924, but some of the modern ones are probably still being researched. And this is a physical problem, is what all of these scientists are saying. However, there are some scientists who believe consciousness is a metaphysical problem, in which case science can't even really weigh in on it because it's almost magic. So what we're focusing on is twisting, stretching, opening up pores, and those disruptions cause a physical disruption of consciousness. If you believe that it's metaphysical, sorry, ain't got none for you.
Kind of, yeah. Well, there's other podcasts for you to listen to, but we're not really going to talk on that.
I'm happy that you wandered over here. I'm happy to engage with you, but we're not going to talk about it because there's really no answer. Yeah, we can't test it.
If you can't test the hypothesis, then what's the point, right? So.
Yeah. So knowing all that, Julian, I'm going to put you on the spot.
Sure.
Do you think that we could easily punch an animal to knock it unconscious, like thinking about all the different ways that you can knock out a person?
Right. I guess it depends, on if this creature has the traits that we talked about based on each hypothesis, right? Like if it's related to twisting at the brainstem, then it's going to need a brain that can twist with enough of a rotational moment.
Enough torque, kind of.
Yes,
exactly. You need to be able to cause enough torque to actually twist the brainstem.
Right.
If it's about pores, it's actually kind of the same problem. You have to be able to punch it with enough force that a teeny tiny brain feels all of that force. Remember when we talked about Ant-Man style physics? He's so small that if he gets smacked, he's super. It's not the size of something really does affect how physics is applied to it. Mm-hmm. And so it gets complicated. You know what else gets complicated? Searching for knockout when it comes to animals, because knockout is what we talk about when we talk about CRISPR knocking out genes, which I don't know if you've tried to search for knockout in a scientific paper anytime in the last 10 years. It's impossible.
It's all CRISPR stuff, huh?
It's all CRISPR stuff.
You mean to tell me there's no studies where people are like, I've been punching this goat to see what would happen?
I have been punching this goat and it is not... I am not sure why it is still awake.
Why are the goats so resistant to not... This is Ivan Drago after he was defeated by Rocky, became a scientist.
But you know what? He needed a new career.
Yeah,
and he was done boxing and he needed something. And he can lift up the goats.
He was like, I will break you.
Meh. And he would just tape a picture of Rocky to it and... I like this. This is good. Yeah. This makes total sense. And it's not at all unethical from a scientific perspective.
Posting all this research on goat punching. Isn't goat punching another thing? That's another thing you shouldn't search on the internet. I'm almost 100% certain of that.
Not. Please don't search that. I'm
100% certain you should not Google that.
Hello and welcome to the International Conference of Punching Goats. I today am presenting my latest research paper, Punching a Goat, How to Knock One Out. I'd like to thank my university for all of their support. Unconscious implies consciousness, so also searching for that when it comes to animals gets you a lot of really interesting stuff. In 2012, did you know this? The Cambridge Declaration on Consciousness was written.
No.
Which said that humans are not the only conscious beings and that non-human animals, including all mammals and birds and many other creatures, including octopuses, possess neurological substrates complex enough to support conscious experiences.
Cool.
Yeah.
Right. So
yeah.
But if it's, I guess, not complex enough, right? This sounds like we're getting into the metaphysical area again, though.
We are.
We're talking about is the fly when I punch it even conscious, man?
Right. Yeah. Exactly. So I had to find a way to search for being knocked out. Can't use torpor, because that's often used when we're talking about hibernation. We can't use, and other kind of similar states. We can't use unconscious because that implies conscious. We can't use knockout because of CRISPR. Thanks a lot, CRISPR. So I ended up using stunned. I could find some animals that we talk about as being knocked out, but let me run down. So we're looking for the smallest animal. So let's start with a medium-sized animal, the alligator.
Oh, you want to punch an alligator?
The brochure from the South Carolina Department of Natural Resources says, quote, once an alligator is captured and brought to a boat or the shore, it can be dispatched. Legal requirements mandate proximity before dispatch. Acceptable methods include a bang stick or handgun. For a bang stick, the alligator's head should be submerged before discharge. Handguns could also target the base of the skull, yikes, and angled slightly forward. Improper placement may only temporarily knock the alligator unconscious.
Okay, I was wondering where you were going with this, because I was like, this sounds like alligator murder to me.
It is alligator murder, which I have to say, Alligator Murder is a great band name. It's been a few episodes and we've had a good one, but that is a great band name.
Alligator Murder.
I would go see Alligator Murder. They would be, I bet you they'd be so fun. Anyway, alligators can be knocked unconscious, or that's what the South Carolina Department of Natural Resources says. But alligators are pretty big. So, cats and dogs.
Oh no, don't tell me there's an article about
found a
dispatching
post.
cats and dogs.
No, I found a story. So, take that as you will. I think you can knock, and we're not talking about anesthesia, by the way. Obviously,
Right.
These animals can all be put under with anesthesia. We're not talking about that. We're talking about hitting an animal unconscious. So I found a post of a guy whose dog was kicked by a bull. The dog was attacking the bull and generally being a jerk, apparently, and the bull turned to run away and kicked the dog full in the head. The dog went flying, and the guy wrote that it landed like a sack of potatoes and it didn't move. He was fully prepared for his dog to not have survived the altercation. Then the dog got back up, and what did it do? Immediately started chasing the bull again.
You're damaging my brain only makes me stronger. I'm not going to learn from this.
I'm not going to learn. I am actively not going to learn from this. Okay?
You've made it impossible for me to reconsider this.
So both cats and dogs can be knocked out, can be stunned by hitting it very hard. It probably does damage their brain. Okay. A Journal of Animal Welfare from 2023 talks about fish, and you can knock them out. But this is where I was starting to run into problems, because it's not like there's a lot of scientific studies of people knocking animals out by hitting them. It's not super ethical. It's not like they'll pass the ethics board if they're out there being like, okay, here's my idea. I'm going to go punch some fish really hard.
I need $100 million.
I've built this fish punching robot, the Fish Puncher 4000.
It's very Simone Gertz.
Yeah, well, Yetch is, she does her best. I think she could build that, but I don't think she would. I love her.
Puncher.
I don't think she would build a fish puncher. She would punch herself with her alarm clock before she punched a fish. And that's the thing. So if you saturate water with CO2 that the fish are swimming in, they'll be stunned, and you can then make them kind of go unconscious. The RSPCA in Australia, which is a humane animal treatment organization similar to the American SPCA, you can smack a fish on the ground or on a rock, and that would stun it. You can see animals do this, but you have to swing it really good, like real like, Freddie Mercury, like, wow!
Or
kind of a
Golem,
swing.
right? Like, tasty fish. Yes, delicious fish. As he smacks the cave fish. Oh my god, that's too good. I don't like that. Please stop.
Okay. So then there are mice. Pet owners. I found a pet owner forum where they were like, how do I feed my mice to the snake? Because, you got to knock them out first because they'll run away. One, how lazy are your snakes, dude?
Right?
Come
Make
on.
them work.
Jeez, make the snake work for it. It's inside of the aquarium. It can't go anywhere. So they talked about how to stun the mice humanely because a lot of them wanted to stun them before they fed them to the snake. And the agreement was that you grab it and fling it as hard as you can at a hard floor, and the impact should knock it out or kill it. Super violent. So is nature. The circle of life. That's how it is.
Just feel like, how humane are we really being here?
Well, snakes are going to eat the mice in the wild. Now they're just doing it in your house.
I know, but like...
It is what it is.
This is to make it less painful for you, mouse. Whap! Like...
It was over quickly, ideally.
Feels terrible. Okay.
No, you're not wrong, because the forum, what I didn't write in my script is there was a discussion of how hard to throw it, because if you don't throw it hard enough, you just hurt the mouse.
Yeah.
If you throw it too hard, it's definitely dead. And it's rough. So
Anyway.
They also found some success in stunning things smaller than mice. And of course, I had to look up C.Elegans.
Oh, okay.
I need like a guitar riff for model organism C.Elegans.
Every time we bring up C.Elegans?
Yeah, like... Guys, if you don't know, you don't know C.Elegans? Oh my God.
I don't know if you can call yourself a science nerd.
If you don't know,
This nematode.
C.Elegans. Yeah. This round worm. It's a model species. It's used for scientific study, and they can be as small as 1 millimeter. And if you put them into a centrifuge and spin them at hypergravity, it will stun them, they will stop physical activity, and then resume. That's probably the smallest thing I could find that you can knock out. But you can't really hit something that's 1 millimeter with any amount of force because they were spinning it in a centrifuge. Any guess how long they had to spin it in there to get it to be knocked out?
Oh gosh, I don't know.
4 days. 4 days at 50 G's. Because it's really hard to apply that kind of force to something that small.
Yeah. C. elegans, by the way, is like the only organism where we have completely mapped the structure of its brain, right?
I don't know if it's the only one, but we have done that. Yes.
Or at least the first one, because it's got a brain that's like, I don't know, 300 neurons, something like that.
Yeah, it's not very many.
Yeah, and so we were able to actually map like the entire brain. So in terms of knocking unconscious research, I could actually see this having some application.
Yeah, they did with this centrifugal force of a 4-day-long 50G spin. And they said
I'm imagining the astronauts like waiting, like, when's it going to be my turn?
They said it will stun them. They'll stop physical activity and then resume after a time. So even 50 G's for 4 days straight.
And they're just like, do they move in like little circles?
Back to normal. Another model organism, the Drosophila.
The fruit fly.
They can feel some kind of pain. So again, ethically, it's tough to study punching them. But they did injure some while anesthetized and found that after the animal is hurt badly, they will try and protect themselves in that way for the rest of their lives and avoid situations where they could get hurt again. But they did, remember how I joked about the fish puncher 4000?
No, they made a fly puncher.
They made it. They called it the HIT device. And
name needs work.
It causes a traumatic brain injury in Drosophila. So researchers can study how their brain reacts to injuries.
It's a tiny boxing glove on a jack-in-the-box. You trick the fly into cranking it. And then bam.
Yeah. So these flies are temporarily knocked out, I think. I'm sure they are. They don't actually say in the study if they are knocked out because they're looking for TBIs and dementia in tiny fruit flies. I love science. This is something that an idiot would stand in front of Congress and say, they're punching flies. And it's like, yes, they're learning about dementia and why it happens.
You don't understand model organisms.
Model organisms, they're the best. So
very useful tool.
Animal welfare journals and the RSPCA were pretty clear that you shouldn't be smacking around animals to see if they can be knocked out. Human blood sports are consensual, and even fish can feel some sort of pain, so it's unethical to punch them to just see if we can knock them out or not. That's not just me saying this. The ethics compel biomedical researchers to care for animals' well-being as best as possible. So anybody who's like, oh, animal research is all bad. I'm not going to argue whether it is bad or not. I'm sure some of it makes people very uncomfortable, and it should. I would love it if we didn't have to do animal research. Sometimes it is necessary. But the scientists are required by law and code of conduct in the scientific community. And some of the rules are the research has to be justified. Animals have to be cared for humanely. Procedures are closely monitored. Animals must be obtained humanely. And if something can be done to the animal while under anesthesia, it should be done that way, which is why I mentioned the Drosophila, because they put them under anesthesia by essentially like making them breathe CO2 so they would knock them out and then they would hit them. And they did it again to study dementia and traumatic brain injuries because this model organism has a brain that, even though it's not like ours, is like enough that we can learn stuff from it. We keep coming back to the square cube law on this podcast.
Yes.
And this is really the baseline for why we can't just punch a small thing. Because the square cube law means that it gets so much smaller and its volume decreases so much, its mass decreases so much that hitting small things, they have much smaller brains by mass, like orders of magnitude smaller. Right. So the physical torque, any of this mechanoporation, anything that's stretching their axons, all of that, you'd need to hit them exponentially harder in order to make any of those things happen.
So ironically, the smaller it gets, the stronger you have to be.
Yes.
To knock it out.
And honestly, I think Sean knew that because Sean said a stronger man than I might be able to knock out a fly.
Oh.
I think Sean intuited, or maybe just misspoke, that you need to be stronger and faster in order to knock out something like a bird.
That's fascinating.
Right?
Like, here I was assuming, like, oh, you're just picking on something smaller. That'll be easier to knock out. But no.
Yeah.
No, it's possibly, like, if you can knock out a huge dude, I ain't impressed, you know?
Go
like
knock out a mouse, dude. Go knock out a fruit fly, bro.
Then come talk to me.
Then come talk to me. Anyway, bottom line, the impact we're talking about needs to be really, really big. You can stun animals, and they'll be disoriented, but then they'll get up and go do what they were going to do anyway, whatever that is. So you smack that fly, you're not probably knocking it out, unless you're super duper strong, like that guy who knocks out goats, who is fictional.
That former Russian boxer.
Who we made up. I mean, we didn't make him up, but we made up.
Russian former boxer. He's still Russian.
Let's take a quick break and come back with Julian's question. Julian, give me your best dinosaur roar.
Oh, God, an asteroid! It's horrible!
Wow, that was not where I expected that to go. We're popping in before the show to tell you about I Know Dino. It's a dinosaur podcast.
You know, we think of those dinosaurs being this thing that's been dead for tens of millions of years. Even so, studying dinosaurs can still teach us stuff that is relevant to the world today.
Yeah, like climate models to help us understand global warming.
Migration patterns of dinosaur lineages, they tell us about Earth's changing continents.
We can also study dinosaur diets, what plants lived then, and maybe what animals and how they interact.
And, this is super cool, many dinosaur injuries, paleopathologies, they're the first known occurrences of diseases.
And they talk about all this kind of stuff on I Know Dino. It comes out every week with new dinosaur stories that you're not going to hear anywhere else. Like, I hadn't heard of a lot of these, which is pretty cool.
You can find I Know Dino on Apple Podcasts, Spotify, wherever podcasts are. And if you found us, you can probably find them. Go check them out.
Okay, and welcome back to That's Absurd. Please elaborate. Now we have our next presentation from Rocky.
Hey everybody, I'm here to talk about how I punch Russians and I want to study their brains.
I'm sorry. That's dumb. That was a dumb joke. Julian, what's your question?
Okay. I was like, oh man, I'm going to have to wait for Rocky to finish. My question this week comes from Mateo, who asks, could we produce enough air pollution to make the sky rain aqua regia? At what point would it begin to dissolve gold?
Whoa! Okay, I have many questions.
Yes, same.
What is aqua regia?
That's the thing that drew me to this, because I was like, I don't know what that is. But Mateo elaborates. He says,
oh, good.
I learned recently that acid rain is made up of SO2 and NOx. NO and then subscript X, because it can be like 1 oxygen, 2 oxygen, 3 oxygens.
Yeah.
Which form sulfuric and nitric acid, respectively. I also know that the substance aqua regia, which can dissolve gold, is also made of those two chemicals. Thus, my question. Fascinating, interesting. Like you said, I'd never heard of aqua regia.
Never.
I didn't know about this. So when I'm going through our little, question database and I see this thing about dissolving gold, I'm like, what?
Yeah.
I gotta look into that. It's just kind of a coincidence that this is like the second rain-related question I've picked in like the last month, but anyway.
Yeah, I coincidentally did another brain question for the next episode, so
we're
going to talk more about action potentials next time around.
Shout out to Frederick from Denmark who asked about terminal velocity of rain, which, by the way, this is convenient. I had a little corollary to that episode.
Yeah?
My brother-in-law, who's a physicist and is still a regular listener, he was literally like the first listener. I showed him our first episode before it released, and he's still an actual physicist, I'll remind you, still listening weekly, which is a massive compliment.
Too bad.
Too bad. He heard that question about terminal velocity of raindrops, and he sent me an article from like over 2 decades ago. But when he was in college, he actually worked with a professor who studied super terminal raindrops.
Cool.
Yeah, apparently it's a phenomenon where like small to medium-sized raindrops travel faster than their terminal velocity should be. And he worked with a professor who studied that. And by the way, they think it's because it's a bigger, fatter raindrop that's traveling faster that then breaks up. And so those smaller droplets are still traveling faster than they should be.
So it's
and
more coincidental that when they're measured, they happen to have just broken up.
Yes.
And so they're moving faster, they're eating more ice cream, they're, because they just broke up.
Yeah, they're working through some stuff. They're all depressed because it's rainy, but they're also the rain.
They are. Do you think raindrops get depressed? Because it's always raining when they're around.
Yeah, it's true. Isn't that it's like a Hitchhiker's Guide to the Galaxy joke of a guy who's like pissed that it's always raining, but it turns out he's a literal rain god and the rain clouds love him and like follow him around.
That does seem like
I love that.
Hitchhiker's
Anyway,
Guide.
Okay. But back to Mateo's question and talking about aqua regia, a.k.a. royal water. That's what it means in Latin. So yes, Mateo's right. This is a solution that can dissolve gold. And people love gold, right? It's got a lot of properties people like. They're drawn to it. It's shiny.
It is shiny.
It's kind of the big one, really. Ooh, shiny. My precious. That's so good, right? Maybe that precious in particular, also because it's infused with the soul of the Dark Lord Sauron, right?
Sure.
But also shiny, I'm sure helps.
I thought you were going to do an airplane facts with Max there. I thought you were going to do our second one.
We do not have time for me to steal airplane facts with Max's bit. Okay.
By the Dark Lord Sauron with a friend.
What's cool about aqua regia, but not as cool.
Sorry. Please continue.
Anyway, so it's shiny, but it also stays shiny, right? It doesn't tarnish, it doesn't oxidize, and so it stays shiny, and therefore it's what's known as a noble metal, right? It's resistant to this oxidation. But it also doesn't dissolve in anything except apparently aqua regia, and that's why alchemists gave it that name, like it's royal water, because only gold dissolves in it. Which, by the way, in learning this, I learned an amazing story about Niels Bohr involving aqua regia and gold and the Second World War. It's really cool.
Okay, are you going to share with the class?
Absolutely. So Niels Bohr was a Danish physicist. He had a institute in Copenhagen, so shout out Frederick, this should be your guy.
What up?
He did a lot of work through this institute where he protected scientists from the Nazis and like helping get Jewish scientists out of Nazi Germany. There were a couple scientists in Germany who had won Nobel Prizes. One was Jewish and the other was anti-Nazi. And they were worried about the Nazis coming and confiscating their Nobel Prizes as a form of punishment. And so they sent their Nobel Prizes to Niels Bohr in Denmark. But the Nazis also had said it's legal to smuggle gold out of Germany. And by 1940, the Nazis had taken over Denmark. And they were coming, probably looking for these Nobel Prizes at Niels Bohr's institute. And so the Nobel Prizes, by the way, they have the names of the scientists on them. They're engraved with them. So it's kind of a dead giveaway that the scientists broke the law and that Bohr's helped them. So Niels Bohr is like, what are we going to do with this? Should we bury it? No, the Nazis are probably going to dig up the garden. What do we do? And a Hungarian chemist who was at the Bohr Institute named Georgi de Hevesi, I definitely said that wrong.
Nailed it.
He said, hey, what if we dissolve them? So they put these 2 Nobel Prizes in solutions of aqua regia, and it took hours for them to dissolve while the Nazis were literally like out marching in the streets around Copenhagen. So I'm sure it was like a very sweaty time for
Honestly,
Niels
I would
Bohr.
watch this movie.
Right?
It's the nerdiest, most intense thing ever. They're just like, I can hear the music. They're like dropping it into they probably, maybe fictionalized, had to leave to go get the chemical somewhere, mix
Right.
it up and put it through all the things. They drop it in and the Nazis are marching, the music is going.
The Nazis are knocking at the door.
And there's only a little bit left, and they got this like extreme close-up of just like the last bit of the Nobel Prize is still foamy and dissipating. Oh, God! And they open the door!
It would be amazing.
I'm honestly, I'm sold.
Yeah, so the Nobel Prizes, they dissolve them completely in this solution, and then they just put like the 2 vials of it up on a shelf somewhere, and it just looks like some brown chemistry liquid. And so the Nazis obviously can't be like, that's a Nobel Prize, right? It just looks like some liquid.
Idiots.
And after the war, they used another chemical process to extract the gold and reforge these Nobel Prizes and give them back to the scientists.
Oh my God,
So
I love nerds so much.
It's the original gold, but it's just like reforged. Oh, it's so good.
I love that.
It's such a great story.
I need a show about this. I need it. Let's just make it.
Yeah.
You and me, let's make it.
It'd be a really cool like little mini doc, I think.
Yeah.
By the way, Niels Bohr, also super good guy. He had won a Nobel Prize by this point, but he auctioned it off to help Finnish refugees that were leaving Finland from the war that Finland was having with the Soviet Union at the same time.
Cool.
Yeah. Okay. So, aqua regia. Cool stuff. Historically important if you're a nerd.
Yeah.
Now, what is it exactly? Well, it's a volatile mixture. It is normally colorless when you first mix the 2 components together, but it turns into this yellow-orange liquid, and it also fumes like crazy. So you have to handle it carefully. It's highly corrosive and also giving off like toxic gas. You have to work with it under a fume hood. Because of this, it's usually only mixed right before you're going to use it. So that's the aqua regia component of this. Now let's talk about acid rain. Mateo's right that acid rain can contain sulfuric acid and NOx, right? NO, NO2, NO3.
Yeah.
These are usually produced from combustion of fossil fuels, coal, right? NOx forms when nitrogen in the atmosphere during combustion gets mixed up with oxygen, and then some fuels also contain some sulfur, and so sulfur mixes with the oxygen, you get sulfur dioxide. And then these things, when mixed with water, can form acids. Rain normally is slightly acidic. It's got a pH of about 5.6. And that's normally because rain, even if there's no sulfur dioxide, it's still mixing with CO2 in the atmosphere.
Yeah.
And it forms carbonic acid. We've talked about carbonic acid a handful of times. One of my favorite fun facts about it. You ever leave a glass of water out overnight?
I was just thinking about that video you made about this.
Yes, this is my favorite, right? You want to tell us about it?
No, I mean, I don't want to steal your thunder, but I think about it every time I pick up a glass of water and I'm like, this water tastes funny. It's because there's carbonic acid in it, because there's CO2 in the atmosphere, and it dissolves naturally into the water that's sitting out. Julian made a video about it years ago, and I think about it all the time.
Yep.
Every time I drink a glass of water and I'm like, this has been out.
Yeah.
I'm like, damn you, Julian.
You go
for
to bed,
teaching me why this tastes weird.
you leave a glass of water out, right? You're like, oh, when I wake up, if I'm all dry mouth, this will be perfect. And then you have it, and you're like, it's bitter. I don't like
carbonic
it.
acid in it.
That's the carbonic acid.
It's literally just CO2 from the air that's dissolved into the water. So cool. So cool.
So we have talked about in the past what makes an acid strong versus weak. If you remember Max's question about using a pineapple to dissolve a human body, episode 26, this is such a great one.
So good.
But that's been a while, obviously, like over 50 episodes. So I will refresh if we have new listeners or if people have forgotten. But there's a difference between something being acidic with a low pH and a chemical compound being a strong acid.
Yeah.
Do you remember the difference?
I don't.
Okay, great. I'll go over it again.
Please tell me, because
been a while.
honestly, every time we make an episode, I immediately forget everything we talked about.
True story. So
That's
relatable.
the science communicator's curse.
It really is. People are like, wow, you must know a lot. And it's like, not really.
No, I recorded it on video, so you know as much as I do.
I have
If you watch
approximate
it.
knowledge of many things, but I don't really know anything. All right. So there are multiple definitions of what an acid technically is, and they get more and more precise, but there's one that's kind of a little too simple, but it's good enough, and it's the Bronsted-Lowry definition of what an acid is. Basically, an acid is a proton donor, some chemical formula that, you put it in water and it releases hydrogen ions, which is just a proton, into the water, and those hydrogen ions can then go and rip other molecules apart. That's why when we talk about inorganic acids and you talk about the chemical formula of them, it usually starts with H and then something else, right? Hydrochloric, HCl.
How I always remember, too, is the pH level.
Yes.
Which most people don't think about what it means, but it means the power of hydrogen.
Yes,
So,
it's the logarithmic scale of how much hydrogen is actually in this liquid.
and I love thinking about it that way because things that are acidic, you're tasting it and it tastes sour. You're tasting how much hydrogen is in it. Mm-hmm. Which is just awesome. Cool. That's what you're detecting the amount of hydrogen ions.
Yeah.
That's so cool.
One day we're going to talk about the way the brain makes sense of the world around us and how we take it for granted and how cool it is. But
it's so cool.
It is cool. Okay, so acids are proton donors, right? But the strength of an acid has to do with how much it tends to give up those protons. So a strong acid will dissociate completely. The hydrogen and the rest of it will completely separate. But here's an important thing to know in chemistry. Reactions can go in both directions,
yes.
right? So sometimes those two components, they get back together. And these reactions will happen simultaneously. Some of the acid is coming apart, and then those components are coming back together, and it goes back and forth until eventually, they happen at different rates, but eventually they'll reach an equilibrium where the forward reaction and the reverse reaction are happening at the same rate. Yep. And so when that happens, you can't make something more acidic. You can't lower the pH by adding more of that same acid because the hydrogen and loose components are just going to get back together again. The pH isn't going to drop. So a strong acid, you can keep adding more and more and more of it, and the hydrogen is still not going to get back together with the what's called the conjugate base very quickly. So you're going to get more and more and more protons. A weak acid likes to get back together again after a breakup. They're like a toxic couple,
Yeah. They're like, screw this ice cream. We got to get back together.
Yeah, exactly. I should call her.
I got to call her. Don't call her.
Do it.
I should call him back. I miss him so much. No. You're better off, girl.
Be strong, acid.
Come on, Heidi the hydrogen. Let's go out.
With all your hydrogen gal pals.
Yeah. Best way to get over a hydrogen is to, pair up with another one.
You don't need that acid in your life.
Honestly, I'm really enjoying this narrative.
That'll be our second documentary after the Niels Bohr Nazi hiding caper, and people will be like, how was this made by the same people?
Yeah, well, that is the podcast that we do. It's a little chaotic.
None of this makes sense. Thank you
chaotic
for being
good,
here.
I would say. Chaotic good.
Okay, so we covered that rain is typically a little bit acidic, but carbonic acid is not a strong acid. However, you can get very acidic rain if you get strong acids floating around up there and mixing with the water droplets, and those can be sulfuric acid and nitric acids, just like Mateo mentions, right? This happens when sulfur dioxide, SO2, and nitrogen oxides, NOx, are emitted, and they go up into the air currents, and then they form those acids, they react with water, and then they come on down. So a small portion of that is natural, does happen naturally occurring, but because humans like burning fuel for energy, we can throw a lot more of that stuff up there and cause the rain to become much more acidic. So thanks to, certain government agencies like the Environmental Protection Agency, though, we've managed to keep control of that. By the way, all this information I'm getting on acid rain is from the EPA because they make this stuff available to the public. Thank you very much. It's good stuff that you do. But they also have programs that monitor emissions and then work to control acid rain. There's a program called the Acid Rain Program, which has helped deliver annual sulfur dioxide reductions of over 95% and annual nitrous oxide emission reductions of over 89%.
Wow.
Yeah.
I mean, I remember being a kid in the 90s, hearing about acid rain and how it was going to damage all our buildings and it was going to just keep getting worse and worse.
Yeah.
And it didn't. Thanks, Richard Nixon, for founding the EPA.
Stuff. Yeah, weird. The only time you'll hear us thank Richard Nixon for founding the EPA and NOAA.
Going to the moon.
Oh, wow. He was the benefactor of what the Kennedy administration started. His name gets to be on the little Apollo 11 plaque because his timing was lucky.
Good timing.
Yes. But yes, it's true. This was a big panic, much like, remember, the ozone layer, and then people who don't know anything go, why were we panicking? It turned out fine. And it's like, because people worked their tuchuses off.
Everywhere, all over the world.
To actually, curb these emissions and keep the bad stuff that was predicted from happening.
Yeah.
Anyway, not that that's relevant in our current day and age.
This is a lighthearted.
This is lighthearted. This
is a lighthearted podcast
of the outside world here.
No, this is a safe space for discussing all of these things.
Not like the work that scientists do is beneficial and also, by the way, good for the economy, because for a very small investment in controlling emissions, you actually save a lot of money because, people have drinking water and don't get sick all the time, and then they can go to work.
They can go to work because they're not dead.
Because they're not dead or very sick. Yeah, it's important. And the acid isn't dissolving the buildings. There's charts from the 1990s of what sulfur dioxide emissions and nitrous oxide emissions look like. And over certain areas, especially over the Midwest, and places like Tennessee and Kentucky and Ohio, big old plumes of these pollutants that cause acid rain. And now today, just like little itty bitty specks.
Thanks, EPA.
Yep, thank you.
Thanks. Regulation.
Good job. Okay, so that's acid rain. Now, there's an important thing that Mateo didn't get quite right. Yes, aqua regia can dissolve gold. Yes, acid rain is often made up of sulfuric acid and nitric acid, but aqua regia is not made up of sulfuric and nitric acids.
Oh, what's it made of?
It's a 1-to-3 ratio of, yes, nitric acid, but the other component is hydrochloric acid.
Ah, that one's a good one. That's one of the good ones.
Another very strong acid.
That's
one
the
with
tummy
nitric
one.
acid. Yeah.
That's my tummy acid.
Yeah, so if you vomited into the atmosphere a lot, maybe. I don't know.
If everyone on Earth vomited into the air at the same time,
could we dissolve gold?
Yes, the answer is probably yes.
Okay.
It's a lot of vomit.
On their own, neither of these two acids can dissolve gold. So what's happening here? It's kind of like a tag team situation. So normally when you put gold into nitric acid, the nitric acid does remove some gold atoms from, your gold nugget. But we mentioned that chemistry reactions can go both ways. A lot of those gold atoms then come out of the solution and rejoin that nugget. So it's going back and forth all the time. But what the hydrochloric acid does is the chlorine ions can actually then latch onto those gold atoms and keep it from rejoining onto the main mass of gold.
Got it.
Yeah.
I think.
So the nitric acid pulls it off, and then the chlorine traps it.
Got it.
Okay. You need 4 chlorine atoms for every gold atom. So there's 4 that'll bond onto the gold and keep it off. So these two acids react with each other. They can form nitrosyl chloride, chlorine gas, and nitrogen dioxide eventually. So that's why it fumes a lot. And as it fumes, you use more of this nitrogen and chlorine, and so the aqua regia becomes less potent. So that's why you want to mix it right before you use it. Now, is there a way, maybe, that we could get these two acids to still mingle in the sky, like Mateo asks, even though one's made from, burning fossil fuels and the other isn't? Well, there's the vomiting that you proposed.
There's the universal global vomiting that we could all have. It would be better, though, because of gravity if we were all in the air at the time.
Yes,
so we
vomiting
all
out of airplanes.
jump really high, and we all vomit through a sieve so that it aerates a little bit.
Yes.
This all seems totally doable.
It's a horrible mental image. Or it's like, cloud seeding, right? Where they...
Yeah. Vomit seeding.
Vomits. If you all rode an airplane, a bunch of very queasy passengers, and then vomited out the window just to make Mateo's dream come true. Or, what I think is probably a more practical approach, you also get hydrochloric acid shot into the atmosphere during volcanic eruptions. So, if, say, nitrous oxide emissions, the regulations on those were rolled back for some reason, I can't imagine why, and then you get some volcanic eruptions that spew out hydrochloric acid, well, maybe you could get them mixing in the atmosphere. I still don't think the concentrations would be very high. And we talked about that, when they mix, they react with each other and they become less potent. But I still think technically you could conceivably have a situation where it rains and there is aqua regia in the raindrops. And so if it hits something gold, it could theoretically dissolve it. Not entirely, unless the concentration was high enough and you let it sit there for long enough, but you still would take little, atomic bits of gold off of it. And technically meet Mateo's criterion.
Okay, well, that's good.
So I had a thought, though.
Oh.
So, Trace, in The Lord of the Rings...
Oh, man, here we go.
What's Sauron doing the whole time? Do you remember? Do you remember the documentary?
He's got a big eyeball.
He's got a big eyeball, right?
He really needs just a little bit, just some, eye drops, because it looks really uncomfortable.
Horrendously.
It's really,
some Visine in the worst way.
Yeah, he really needs
no
just
wonder
a little bit
irritable
of
and murderous
eye drops, because he's got to get something in that. There's just, there's dust in the air. It's got to get in there.
Right.
Be really
dust from what? What might be irritating his eyes?
Mount Doom, a volcano that's nearby.
Right.
Volcano that it was where the ring was forged, where it was made, and the only place that it can be unmade, as far as I've heard.
Here's the thing. I think Tolkien may have accidentally created another way that the ring could have been destroyed in light of this information about aqua regia.
Wait a minute. So we could have a volcano that's spewing the HCl.
Right. That's one important component. And the other important part, what do we need from that?
We need some NOx.
We need, from, say, some industrial activity that's being waged without any regard for nature, right?
Yeah.
Say if we just had this giant, we took a forest and we cut it all down and we turned it into a big, weapon forging, war machine making, Urk-hai breeding facility.
So gooey.
Right? And we're pumping out all of this waste from burning fuels like coal into the air.
Yeah.
Now, by the way, hydrochloric acid can get into the atmosphere from an eruption, but it can also coat the volcanic ash that's erupting. So sometimes this will happen, these hydrogen halides, hydrochloric acid was one of them, will coat volcanic ash and then be spewed up into the air. And then when this dust settles, if it goes into the drinking water, it can actually cause drinking water to become acidic.
Can it be spread really far, I imagine, as well? Because, the ash gets shot up into the jet stream and it can go far, far away.
Very far. Very far. If this is just going to cause aqua regia in the atmosphere, like I said, I don't think it'll be very potent by the time it lands. It's going to have to somehow, land on the one true ring if it were to dissolve it. But what if instead, you had volcanic ash traveling a long distance, like you mentioned,
Sure.
and it settles, in a pond... And it makes that pond very...
somewhat acidic
with hydrochloric acid.
Okay.
Right?
I'm following.
And then let's say there's sitting in this pond for a period of centuries.
Thousands of years. And some things that should not have been lost were forgotten. Or maybe they should not have been forgotten, but they were lost.
Let's say there's a gold ring in it.
Oh!
Right? And so you get the fires of Mount Doom putting... hydrochloric acid into this pond that the ring is in.
Yeah.
And then you also get sulfuric acid from the industrial pollution that Saruman is putting into the air while he's making his Uruk-hai army. And it rains down in this pond and it makes the pond have a lot of aqua regia in it. And it starts dissolving the ring.
I mean, he didn't start doing his industrial stuff until
after Golem had found it.
After they'd already found the ring.
It's true. But what if...
You look like a crazy person. I
am a crazy person. What if Bilbo Baggins had never found the ring in Gollum's little cave, and Gollum had kept it stashed somewhere, maybe in the pond, for safekeeping, and this pond became more and more filled with aqua regia, and the ring just dissolved itself?
My precious!
What if
Sauron, is lost?
Through just the natural course of trying to redominate the world in almost like a heavy-handed metaphor for industrialization, damaging the planet. What if he was his own undoing?
Wow.
It could have happened.
Or did
And
it?
then Frodo could have just kicked back in the Shire chilling.
Which he did for a long time. It's
did.
not really clear
It's
in
not
the
in the
films.
films, yeah.
But he found it, and then it was like a decade or 2 decades or
Yeah.
something before he comes back, and he's all like, hey, you still got that ring? And he's all like, I gotta go get it out of this box. I know it seems like you were just here yesterday, but it's been like 20 years.
I'm listening to the Lord of the Rings audiobook right now, narrated by Andy Serkis. He's very good.
Oh,
But
cool.
yes, the opening sequence is so much slower
Yeah,
than the movies.
everything in the books are so much slower.
Not to mention, they have Tom Bombadil in there, and he's not.
Oh my
anywhere
God,
in the
that's a
movies.
whole side plot that I'm kind of glad they cut out, but wow, that guy could kick butt. You know what
Yeah.
I'm saying? Anyway, that's not neither here nor there.
And sing fabulously. But yes,
Sing
Tolkien,
super fabulous.
not really a novelist, we should note, right? He was a linguist who was basically making a book that he could write as many elf languages in as he could, and it just happened to have a story. By the way, apparently, fun other little anecdote. When Tolkien was reading this to his friends, other literary writers at the time, apparently at one point, Hugo Dyson exclaimed, "Oh, not another elf."
Honestly, I feel that way myself sometimes.
Sometimes, yeah, when you listen to it, you're like, oh, man.
Another one! I have to remember this one too. There's too many thuths in your name.
Okay, so, Mateo, all that is to say, aqua regia, not quite the chemical solution that you thought, but hypothetically, yes, I do believe it should be possible to either form it in the rain or in groundwater or drinking water once, say, volcanic ash and acid rain mix. And yeah, you could, given enough time and enough pollution and volcanic eruptions, and depending on how much gold you were using, eventually dissolve gold in it.
Cool. Wow, that's neat. And now I also learned about aqua regia, which I had never heard of. So thank you for
either.
that, Mateo. That was super neat to learn about.
Definitely. Very cool. Well, that is going to do it for this episode of That's Absurd. Please elaborate. The show was written, produced, and hosted by me, Julian Huguet.
And me, Trace Dominguez.
It was produced and edited by our precious Kyle Sisk.
Kyle Sisk. Yes, Kyle Sisk.
It was his birthday the other day.
And it was his birthday. It's
Happy
my birthday,
birthday.
Precious's birthday.
Special thanks to listeners who submitted questions featured in this episode, Sean and Mateo. If you would like to submit questions, you can look for the form down in our show notes. Email us, hello@that'sabsurdshow.com. You can visit our website, that'sabsurdshow.com/ask. You can even call us 302-TAPE-SHOW. That's TAPESHO.
If you've decided to join the Patreon, we really appreciate you, especially our absurd administrators, Les, Adam, Austin, Pinky, and Jonathan. Thank you so much for joining at our absurd administrator level. Please leave a review of our podcast wherever you are listening. We have so many reviews, Julian. I don't know if you went and looked recently at Spotify. We have almost 300 reviews, or at least, star ratings. So thank you to everyone who has rated us. That is amazing. I teared up.
I keep getting burned every time I go read the
Look,
reviews.
there's still people are reviewing and writing comments like Julian is also good, which I really appreciate. I love it. Please keep doing it. I love it. And if you look at our rating on Apple Podcasts, I just want to point out, Julian, because I think you're off the hook now.
Oh, am I?
We're a 5 out of 5.
Oh, thank goodness.
Because of the way averages work. However, if you look at the little graph, it's a bunch of 5 stars and 1 2-star, which we all know what that says. If you haven't read it, everyone, go look at our most critical review. It's excellent. So thank you to everyone who's left a review. Thank you for everyone who has sent in questions. We could not do this show without you, the listener. You are the reason that we are able to do the show, not just because you listen to it, but because you send in questions. So keep sending those in. We love them. We've got some really great guests coming up who read these questions and are just so positively pumped. It's really fun.
Absolutely. And lastly, a special thanks to those listening on Nebula. Nebula listeners get access access to ad-free versions of episodes. That's on our video feed now, because we got a Nebula video channel. You can support us and other fantastic creators, can't praise them enough, that are also on Nebula. You can do so by going to go.nebula.tv/that'sabsurdshow. Also, if you're not on Nebula but you want to see a video version, you can check out our YouTube channel. There's a link in the show notes, but you can also go to youtube.com/@trace-elements because we love memorable URLs.
I'm working on that. I'm working on it.
So yeah, go check out that link if you want to see, our faces flapping around while you hear all the same information you just heard.
And as we say at the end of every episode, because we have such a great catchphrase, Alligator Murder is a great band name, and I think their first album should be Vomit Seeding.
Ooh, yeah.
And remember, like we say at the end of every episode, Aqua Riga in the rain, on a boat, on a train, Aqua Riga with a fox in a box, with a Nobel on a shell. At the end of every episode.
With a sheep herder during alligator murder?
With a vomit on a comet? Oh, I am going to do that.
Oh, yeah, you are.
If you want to
I'm so
join me on a
jealous.
vomit comment, this is not really related to the show, but you can go to spaceforhumanity.org/flywithtrace and apply. You have until April 15th, I think.
You know what I love about our outros is how succinct they are.
I agree.
If you had Aqua Riga and it dissolved gold and then it rained, it'd be a golden shower.
I have no comment on that.
We're gonna end it right there.
Thank everybody for listening. We'll talk to you next time on That's Absurd. Please elaborate.